Okay, hi guys. So in this lecture, we'll be first seeing the states of matter. Then we'll be moving on to very important concept, which is gaseous state. Okay, so first we'll be comparing various states of matter, that is solid, liquid, and gas. So let's get started. So states of matter. Okay. So we have solid, liquid, and gas. Okay, so first we talk about the shape of different states. So the shape of solid is obviously definite. Okay, for liquid it is not definite, and for gas again it is not definite. So for solid this is definite, not definite, and again for gaseous or gases it is not definite. Next, let us talk about volume. So for volume of solid is fixed. For liquid it is definite, and for gases it is not definite. Let's talk about then intermolecular spaces. So intermolecular spaces in case of solids is minimum. For liquids it is moderate, and for gases it is maximum. Okay, next let's talk about density. Density of solids is high. For liquids it is low, and for gases it is very low. Okay, next let's talk about the mixture of solids. So mixture of solids is heterogeneous in nature. For liquids it may be homogeneous or heterogeneous. And for gases it is always homogeneous. Okay, now let's talk about diffusibility. So diffusibility in case of solids is high, or rather not high, negligible. For liquids it's moderate, and for gases it's very high, means they can very much fill up the entire space, even through a when it's allowed to enter the room through a small hole. So it is having high diffusibility. Then compressibility. Talking about compressibility, we would have that it is incompressible, and this is again incompressible, but obviously it is more compressible than solids. Incompressible, but still more than solids if we have to compare them relatively, and gases are highly compressible. Okay, so with this we come to the starting of a very important concept, which is gaseous state. Okay, so four measurable properties are required to be described, or rather are required to describe a gaseous system. Okay, so four measurable properties required to describe a gaseous system. So first let's define those for ideal gas. So for ideal gases we have seen already the equation that PV equals to nRT. So 4 measurable properties are pressure, volume, number of moles, and temperature. R is a gas constant. So let me write all those properties. So these are pressure, number of moles, volume, and temperature of the gas. Okay, so we'll just write a following equation, wherein we actually see that temperature in some unit minus the melting point of that substance again in the same unit divided by boiling point minus melting point. This term is constant. Okay, so just remember this formula, that whenever you have to convert or have, you are given some constant and you want to have the temperature in some unit, and given the melting point and boiling point, you can find the temperature at which it is currently stored for a given constant. So using the same formula, we can actually use this formula to have, let's say we have a temperature in degrees Celsius minus, let's say in degrees Celsius melting point of water is 0 degrees Celsius, boiling point is 100 degrees Celsius, melting point is 0 degrees Celsius. This should be equal to temperature in Kelvin minus melting point of water uh, in terms of Kelvin, which would be 273. Boiling point would be 373 minus 273, and in terms of Fahrenheit, we can see that terms of Fahrenheit, melting point of water is 32 degree Fahrenheit, boiling point is 212, and again melting point is 32. So from here we can actually establish the relation between temperature in degree Celsius and temperature in the other two units, which are degree Kelvin and degree Fahrenheit. So temperature in degree Celsius upon 5 should be equal to temperature in Fahrenheit minus 32 over 9, or we can write that 9 by 5 temperature in degree Celsius would be equal to temperature of water in degree Fahrenheit minus 32. So this is, just remember this formula to convert any degree in Celsius to degree in Fahrenheit and vice versa. Okay, next let's talk about volume for an ideal gas. So volume for an ideal gas is simply the volume of the vessel in which it is kept. So volume of the vessel is equals to volume of the gas. Okay, and volume of the gas is nothing but the volume that is available for movement of gas particles. So this volume for ideal gas can be defined as volume that is available for ideal gas for movement of the gas particles. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing volume for an ideal gas, and then we'll be continuing on seeing the more properties like pressure for a gas, and then we'll be seeing barometer and manometers and things like that. So till then, good luck and goodbye.